Well, good morning, good afternoon, or good evening, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, Managing Editor at MediaOps and moderator for today's event, and I welcome you. We have a great event on tap. We're going to mix things up a little bit for you this morning. We're actually going to start things out by launching a poll that you can go ahead and answer while I'm going through the housekeeping items and introductions, and then we'll kick off today's webinar. The polling question should be up on your screen now. The question is, where do you run your SQL Server databases currently? You can select from Azure, AWS, Google Cloud, on-premises virtual machines, or on-premises bare metal. And while you're making your decision, just want to go over the housekeeping items for today's webinar. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions in the questions tab, and we will get to as many as we can during today's question and answer session. Also, at the end of today's webinar, we will be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, I'm going to go ahead and close the poll and make the introductions for today's presenters. First up, we have Dr. Jake Dolezal, who is a practice lead at McKnight Consulting Group. And we have Arvind Gupta, who is the Principal Solutions Architect lead at Diamanti. Gentlemen, thank you so much for joining me today. I really appreciate it. And Jake, I know you're going to be kicking us off, so I'm actually going to put myself on mute and let you get right to your presentation.
Well, thank you very much. I appreciate that. Good morning and good afternoon to everyone. I want to welcome you all to this webinar. First of all, I want to introduce again myself. I'm Jake Dolezal with McKnight Consulting Group. And if you're not familiar with our organization, we have been doing database testing, benchmarking, and other analyst activities for many years. We are also field experts, and we're a third-party validator of performance, among other factors of selection and criteria that go on in the information management field. And although this testing that you're going to see about today comprises a good deal of activity for us, we are primarily consultants, and we work with an A-list of clients, and we help deliver strategies and solutions as a vendor neutral and trusted partner. So we not only do we test this technology, but we also implement it in the field. And so we have a great idea of how that works. Before we get into the presentation, though, I do want to present and introduce to you my co-presenter from Diamanti. I invited Arvind to join us because I think he can do a great job at shedding some light on some of the results that we uncovered. So Arvind, if you'd like to introduce yourself, go ahead.
Certainly, thank you, Jake. Hello, everyone. My name is Arvind Gupta, and I lead the solution group here at Diamanti. I've been helping lots of our customers to bring SQL Server 2019 to production on Diamanti platform. And we being in hybrid cloud arena, customers always asking when they should run this on public cloud versus on-premises. And there is no really clear answer to it. So there's so many factors to be considered. So when this opportunity came up with McKnight Group, I thought this will really help our customer to answer at least some of those questions. And I'm really glad we collaborated with McKnight Group on this. I'm amazed to see how well Jake and the McKnight Group handled this project while being completely unbiased when doing all these results. And personally, I have gained so much knowledge and experience while working with Jake on this. So I'm really excited to see the result, Jake. Let's move forward.
Okay, great, thank you. Yeah, so no doubt about it, there are many benefits to containerization, but I have a feeling that most of you are already convinced of that, and we're here today to talk about performance. And even though performance is just one of many selection criteria when it comes to selecting a platform, it's still very important, and it's going to be primarily what we talk about today. However, we're also going to talk a little bit about cost, because that is another huge component to this. And in fact, we're going to join them together and using an industry recognized price per performance calculation method, but we'll get to that in just a minute. Before we get into any description, I do have a quick disclaimer to make. As Arvind mentioned, we do at McKnight run all of our performance tests to strict ethical standards, and the results that you're going to see today are an objective and unbiased set of results from the testing methods that we will describe. We hope even that you could we could describe it well enough either in this webinar or in the paper that accompanies this webinar, that you could even replicate this and see the same results yourself. So we leave it up to you to decide for yourself how to qualify this information for your own individual needs. And again, this is just one of many selection criteria. Now, we're also not making any claims that we did a third-party certification with the Transaction Performance Council because we did use their testing methods. Unfortunately, the TPC usually sticks to bare metal technologies when they publish results, and they're a little bit new to the containerization and cloud-based world, so we understand that and we recognize the difficulties in testing that. So we'll cover all of that today. All right, so let's get right into it, shall we? So as you well know, running containerized databases with Kubernetes, performance characteristics of the platform are very critical. High performance database workloads, particularly SQL Server, depend a lot on storage I/O, and our test results will show how that is. So if you have a Kubernetes platform, it must be highly resilient with no single points of failure or performance bottlenecks. So what we did was we evaluated 3 different platforms, they being Diamanti's enterprise Kubernetes platform, which we considered to be a hybrid cloud. And I think Arvind can talk a little bit more about that in a minute, about what that exactly means in the context of Diamanti. But the other 2 you may be a little bit more familiar with, and that is Amazon's Elastic Kubernetes Service, or EKS, and Azure's Kubernetes Service, or AKS, which are of course only in the cloud. Now, let's look a little bit deeper at a couple of these platforms, or these 3 platforms. First, in AWS with Elastic Kubernetes Service, I show 2 deployment options, but actually there are 3. You could stand up your own EC2 instances and build a Kubernetes cluster from the ground up. Install it yourself, build your own. Or you could use a technology like, or deployment option like COPS or something like that. But AWS, with their Elastic Kubernetes Service, offers 2 options. One is a managed deployment, and you still get to choose your EC2 instances, and the storage options that you have are the same. They do have a third option, or I guess in this case, a second option. That is a completely serverless platform as a service. It involves AWS Fargate. We did not test this option because it is difficult enough to test in the cloud, but when you obfuscate the underlying infrastructure, it gets even more difficult because you don't know exactly what you're interacting with behind the scenes. So we stuck with the managed deployment on EC2 so that we could select the EC2 instance type and the storage options as well. Here's what we chose. We used the R5D 8X large. First of all, these are Nitro-enabled EC2 instances, and if you know much about AWS, their highest end is the Nitro-enabled. It's a hypervisor type technology, but it also pretty much doubles the storage I/O throughput capabilities of the EC2. Now, the other thing is we tried to use the latest and greatest. Now, there is an R6 EC2 instance available now. Unfortunately, when we did our testing a few months ago, it was still not, even though you could buy it as EC2, you couldn't deploy it through Elastic Kubernetes Service. So we choose the next best thing, which is their second latest and greatest, which is the R5D. Has 32 Xenon 8000 series processors. It's an Intel-based platform. Now, when you use Amazon, you have several storage configuration options. They have a their elastic band storage, which is basically where most of the storage is allocated and connected to EC2 instances. First, there is a general purpose class, which consists of two, which is the GP2 and the GP3. We would have loved to have tested the GP3, but again, it was not at the time. It may still not be, I'm not sure, available to the EKS instances. So we did do the GP2. Now, the thing to know about that is you get a fixed number of IOPS per gigabyte of storage. In this case, they measure their IOPS in 16K, the 16K size. When we get into some conversations about IOPS later on in this presentation, we're going to be talking about 4K IOPS. So it's a slightly different size, and I don't want you to get confused by the numbers. But that's how both AWS and Azure measure IOPS, is in the 16K size. Now you get 3 of those per gigabyte. So if you have a 1 terabyte drive, that translates to 3,072 IOPS. If you have a 2 terabyte, and so forth, keeps going up. So the other type that we tested are the provisioned class of IOPS. This is where you get to pick the size and the IOPS and provision those separately. Now, with the Nitro-enabled instance, we were able to get up to 64,000 16K IOPS, and we tested both the IO1 and the newer IO2 class. Second, we also tested Azure Kubernetes service. Again, three real options. One is the build your own, which we don't mention here. 2 is another, again, a managed deployment, very similar to the Elastic Kubernetes service of AWS, where you get to pick your Azure VMs. And then, of course, they also have the serverless platform as a service model as well, which, again, for obvious reasons, we did not test. Now, in this case, we used the Azure virtual machine of an E32AS v4. It's their latest and greatest in that family. It's very similar in specs to the R5D. There's 32 processors, except these are an AMD based technology, which actually has a slight difference in the measurement, and we'll show you what that looks like when we get to the results. Now, for storage and the storage provisioner that's provided through Azure Kubernetes service, you have a couple of options. Now, there is even a lower option, even a cheaper option called standard disk, but I don't recommend that for any type of production workload. It would be more for if you just IO was not important to you. So with this, we chose premium disk, which also has a fixed IOPS per disk size. It's not as neat a formula. It's more of a, if you have a 1 terabyte drive, you have 5,000 16K IOPS. If you have a 2 terabyte drive, I think it's 7,500. Don't quote me on the math there, but I think that's in the ballpark. Also, there is UltraDisk, which is Azure's fastest disk, and you can get up to 80,000 16K IOPS. And the other interesting thing about this is you can also provision how much throughput you want, and we did the maximum of 2,000 megabytes per second. Now, the downside to UltraDisk is it's very expensive, and you have to pay for that, but we'll get to pricing in a minute. Now, for the Diamanti platform, I really would prefer that Arvind describe it to you. He'll do a much better job of helping you understand their technology. So, Arvind, please take us through this slide.
Absolutely, Jack. So, Diamanti is an enterprise Kubernetes platform for the hybrid cloud. And we have many products which covers the full spectrum of hybrid cloud, whether it's you're talking about on-premises private cloud or running Kubernetes workload on any public cloud. And as you can see in the right side of this diagram, Diamanti Spectra on the top is a single control plane for the hybrid cloud. And Diamanti Ultima is the data plane of the hybrid cloud, providing enterprise level data services across public, on-premises, or even the edge clouds. So essentially, anywhere you need to run Kubernetes workload, Diamanti got you covered. So, but for the product which we used for this benchmarking exercise was Diamanti D20 HCI platform, which brings the simplicity and features of the public cloud to the performance of on-premises. So it's a bare metal hyper-converged platform, which is supercharged with hardware offload acceleration. So it's a complete all-you-need high-performance platform to run Kubernetes workload in your own data center. So from the configuration perspective, it was a 40-core 512 gig memory box with the storage side compared to Azure and AWS. The IOPS are not limited. You can definitely control with performance steering and all that, but you can reach like around 1 million 4K IOPS, and there's no limit on the volume size. It's not per gigabyte kind of size limitation. And on top of we have QoS guarantee for both networking storage, which we'll talk later. So I won't take up much of your time, Jake. If you give me time, I might end up talking about Diamanti whole day. So I'll just let you focus on the benchmarking result itself and not Diamanti at the moment.
All right, thank you, Arvind. No worries. Yeah, we like hearing about that, so that's great. So here's what we tested. So let's describe the nature of the test. Of course, everyone is familiar with SQL Server. It's obviously a fairly ubiquitous database out there, been around for a long time. It makes a really good choice for multi-purpose workloads, both analytical or transactional in nature. We see it a lot when we engage with our clients. Another thing that we did was we used the public Docker images of from the Microsoft certified repository. And we did not do any tuning. We took these images right out of the box. We made only really changes to the pods themselves, which I'll show you in the next slide. But really, it was really about testing SQL Server out of the box, just as you would probably use it at first. You may, when you get into your own system admin processes, you may decide to tune the database a little bit for your own needs, but we didn't want to do that for testing. We wanted to just go with a straight out of the box configuration and put everyone on the same level playing field. Now, for the configuration of the pod, we use the RHEL 7.6 version image of SQL Server 2019 Enterprise. Now, here's an interesting thing to note. We did test a number of CPU and memory configurations of the pod size, because we tried to imagine applications of a different size or databases of different sizes. So we did test a few. We all found that the performance was still pretty much consistent. We got the best results across the board with 32 CPU, and then we paired that with 32 gigabytes of memory, and that actually is a pretty good constraint on the memory for SQL Server. And what we were attempting to do was, again, to highlight the performance of the storage IO. So when you constrain SQL Server's memory, guess what? It drives more IO to the disk. And in fact, we wanted to drive as much IO as possible to the disk so that we could measure and see what the differences were between these platforms. Now, the testing that we did uses the Transaction Performance Councils I mentioned earlier. They're TPCH. This is a benchmark that has been around for quite a while. It involves about 8 different tables of customer and part and order and typical tables that you might see in a business-oriented type world. It also has 22 queries that go with it, that are paired with it, that are an ad hoc based. Again, this benchmark, you can say what you want to. It's has some applicability industry-wide, no doubt about it. It's been around for a while. The specifications, if you're really interested in it, there's several hundred-page specification document on how it is built and how it is run and how it should be executed. We followed those specifications. We also used HammerDB, which is a free and open source implementation of the TPCH. Now, there is a version 4 out now. There wasn't at the time. It came out, I think, around the first of the year. But anyway, we used a 3.3 version, and using that, we implemented this test. Now, what happens in a TPCH benchmark is a 2-phase approach. Now, there's a build phase and a run phase. Now, the build phase you only really do once or a few times just to build a different configuration, and then you repeat the run phase over and over because we don't actually do any updates or changes to the database. We just are running ad hoc based queries. So with the build phase, you have a choice of scale factors. And a scale factor basically tells you in gigabytes the initial size of the database. Now, what happens there is we chose something, we were in the medium application. Now, we've tested run the TPCH on other platforms. We've done everything from up to 30 terabytes, 100 terabytes, huge, but that's more of a data warehouse type implementation. We're more interested in the medium-sized application because we are using a single pod of SQL Server, 32 CPU. Again, it's not the largest instance of SQL you'll see out there. So we use the 100 and the 300 gigabyte scale factors, and I think there's plenty there. The other thing to note is that we did try a 1 terabyte. Some of the load times on AWS and Azure were really long, and it just protracted out the testing, and the testing took a long time as well. So we abandoned that approach, and we found that 100 and 300 yielded the results that we were looking for. It provided enough differentiation so that we could make reach some conclusions there. The other thing is, so during the run phase, what happens is you have a number of virtual users, or you might call these streams, or concurrent users is what I usually refer to them. But basically, it's a number of user connections or threads that are running queries in parallel. And so 22 queries will be queued up for each thread in a random order, so that say thread 1 will start with query 3 and then move to query 19 and then query 14 and so forth, and will continue on until all 22 queries are finished. Then, so what you do to measure time for this overall workload is whenever the test begins, you start the clock at that moment when all 1, 8, 16, 32, and you could choose any virtual users you wanted, start their queries. And then when the last user finishes their last query, that's when the test is over. And that's how you get the elapsed time from that. So we repeated this test a number of times with multiple streams, 1, 8, 16, 32, as I mentioned, multiple scale factors, and to yield results. It was a long process to go through and make sure that we were very rigorous and very fair and kept everything equal across the board. So now let's get to the results, what you all came here probably to see anyway. And again, this is scale factor 100, and this is the 32 parallel streams running at the same time, the total execution time from the beginning of the test to the end of the last user finishing their last query. So as you can see, Diamanti was the fastest. So the lower the bar, the faster, the quicker the test completed, which means it was able to finish, obviously, the test earlier. So what we observed was fairly interesting. With the AWS IO1 and IO2 performed about the same, not a great surprise there. IO2 was just a tinge faster, but it was still 4 times slower than the Diamanti. Now GP2, as you can see here, the general purpose storage, less IOPS, it took 12 times longer to finish, and then you can see 100, that's seconds, so 159,000 seconds, that's several hours, as you can see. And then with Azure, what's pretty interesting there is that Premium did reasonably well, considering that it's sort of in the same class as GP2, 75,000 seconds. Azure Ultra was 4 times slower than Diamanti at 50,000 seconds. And so I thought these were some fairly interesting results to begin with. We also bumped up to 300 scale factor. Now keep in mind, with a 300 gigabyte SQL Server and with as much constrained memory as we are having, the temp DB gets pretty big. In fact, you need at least a 2 terabyte drive in order just to make sure that you don't run out of disk space on your pod. We'll get to that later. But that's an interesting point to make, is that there's a lot of I/O going on, not only with the database, but with the temp DB and several things going on. Now, again, at 300, we tested up to 8 streams because we're at 16 and 32 on a few of these platforms. We started to experience some SQL Server errors, and whenever you have an error, you can't really use those results because it doesn't, you can't really constitute it as a fair, complete, clean run, as we call them, a clean run. But the results of what we did get was really interesting. On IO1 and IO2 Nitro-based instances, they were 6 times slower than Diamanti. We did not do GP2 because it would have taken 5 days to complete the test, and we just didn't have the patience for that. So also on Azure with Ultra and Premium, you can see 4 to 6 times slower than Diamanti as well. Now, price performance. I really don't want to explain the math of all of the price performance calculation, but this is the TPCH method for doing so. It's a little complicated, but at the same time, it does yield a fairly consistent result. And we used their method because that's what, again, we're using the TPCH, so we're going to go by their methodology here. But basically, there's 2 calculations. There's a power calculation, and a power calculation is more interested in the single stream. So one user, how powerful is the system, or how able is the system to be able to push and finish individual queries? And then there's a throughput. And throughput is where you have, you take the number of streams or the number of virtual users and figure out how much it can get through all at one time. So how wide is the pipe? So how hard can it push, and how wide is the pipe for executing queries? Then you combine those 2, multiply them together, take the square root, and you get the TPCH's QPH measurement. And again, what we're trying to get for is how much query processing power and throughput do you get for your money? That's the question that we're trying to answer with the price performance metric. So now, how did the other piece of this equation, of course, is price. If you see the paper that this webinar is referring to, there we go into a great deal detail about how the pricing was. Our objective was to give each vendor the best possible pricing. Now, this is where it gets a little complicated with the TPC, because they define it as a system under test. It's their guidance. And a system under test doesn't really take into effect that a Kubernetes is a cluster, and there's multiple instances, but there's only one database pod on one single node by itself. So we tried to take the best of both worlds, and we only priced a single node's worth of for this. We didn't price the entire cluster, because you may have multiple nodes and you may have multiple pods doing all kinds of things, but really we're only interested in the smallest unit of processing with the SQL Server. So that's why we only constrain this to one cost of one node. We also, you want to establish a 3-year total cost of ownership. So you have to take into account compute, storage, networking, and support. So we tried to give all 3 platforms the best possible price. So with AWS, we took that single EC2 instance, that R5D 8X large, okay, and we used their cheapest possible public pricing, and that's a 3-year reserve paid all up front. So I'm going to buy an instance for 3 years, and I'm going to give AWS all the money up front. So that gives you the very cheapest price. Same thing with Azure. We used the 3-year reserve pricing, and they even have a 1-year reserve on premium disk, and we use that for when we priced our premium disk solution. And of course, we would pay for that all up front. So we wanted to give them the best possible pricing as well. And then with Diamanti, we used their subscription-based model for that single D20 that Arvin mentioned, and we used the sticker price. But I'm sure you can talk to their sales to get maybe even a better deal than what we experienced with the sticker price there. But again, we took their public-facing pricing, the best possible price on all 3 of these platforms. So here's what that looks like. When you do that math with the results that we got, this is what we found. So Diamanti was cheapest in terms of price performance, so the lower the bar, the better. And we saw that AWS's GP2 was 4 times more expensive, but again, remember how it performed? So that's where the price comes in. It's considerably cheaper than the IO1 and IO2 systems, because the storage is so much cheaper. So it's only 4 times more expensive. Now, the IO1 and IO2 are about 8 times more expensive. Look at Ultra. Ultra turned out to be it's the most expensive of the solutions that we priced and used, and it was, even though it performed better than like GP2, it was 11 times more expensive. And then Azure Premium Storage actually did pretty well. It was only twice more expensive, because for its storage class, we thought it performed reasonably well. So that's the 3-year, and then when you look at, that was with 100 scale factor, so the 300 scale factor, or the 300 gigabyte initial database size, it changed even more. We had the AWS, we didn't test GP2 because of the length of the test, but with IO1 and IO2, it was 13 times more expensive. Ultra was 10 times more expensive, and again, Azure Premium storage was twice as expensive. Now, another thing we measure and we look at is, again, remember when I mentioned we did 1, 8, 16, and 32 virtual users at both scale factors? Well, this is what we call performance degradation, because as you introduce more users into the mix, more people executing queries, the total execution time obviously goes up. And we saw this. So if you look at down here in the bottom left corner, that's where a single user test results were. And as you can see, they're kind of clustered close together, but as you added users, you get up to 8, to 16, to 32. You can see how that performance spread, and it's fairly linear. I mean, there's no curve to these lines, so it was easy to fit a line to them. And you can see how flat, which means really good or less degradation as you add users, and the more steeper pitched line like the AWS GP2, you can see how the performance degrades because, you know, of the power and throughput that's available there with that storage option. Same thing with Azure, a little bit different, but it's basically the same concept. And again, as you might expect, Premium had the most degradation, followed by Ultra, and then Diamanti had the flattest line, so it had the least degradation. So the more users you added, and we even did a 64 test with Diamanti, and it stayed with this same linear trend. So if you wanted to draw the line on out a little bit further, you would see it followed that same linear trend. Now, why did we experience what we did? Well, again, and I alluded to it already, but really it came down to IO, and IO really is king or queen in this case when it comes to this level of performance. So what we found was then, again, we're measuring 4K IOPS. So this is different from the 16K IOPS that we talked about earlier with Azure and AWS, but this is what we observed when we measured 4K IOPS. Again, Arvind alluded to the fact that you can get up to 1 million or more. We did. Our max went slightly over 1 million, but the average held around nearly 900,000 4K IOPS. IO1 and IO2, 140 average with a 208 max. GP2 was lower than that, 56,000 average, 64,000 max. And then Ultra, which was interesting that their average and their max are really close together, which kind of tells us that we definitely hit the ceiling there, and we were certainly chopped off at the top, so to speak. This is once we got to our stable, that's about what we experienced. And so you can kind of see the difference, and this explains a lot why we saw the results that we did earlier on. Now, what's going on more? So we did, again, we took SAR measurements and IOStat, which of course are Linux system stat measurements. So we just used those basic out of the box measurements. And here's a difference. This slide's a little bit hard to interpret, but basically you can kind of see the difference between the Intel and the AMD architectures of AWS and Azure that we used. But basically there's two things we look at. We look at the percentage of IO weight that the CPU, so how much of the CPU's time is waiting for IO, and then there's the A weight, which is the application weight, and that's sort of the same thing. It's just how much time is the application waiting for IO. So each platform reports it a little bit differently, but as you can see, the lower the better. With Diamanti, we had 5 millisecond A weight, and only 0.3% of the CPU's time was spent waiting for IO to become available, as opposed to AWS, where even though they had fairly low A weights, 44 milliseconds in this case, they saw 33 to 40% IO. So 33 to 40% of the time, the CPU was twiddling its thumbs waiting for IO. Then on the Azure side, kind of flips, low CPU IO weight percentage, but high A weight. So we're talking nearly half a second, 300, 400, nearly 500 milliseconds of A weight time. So that I think is another clue as to what might be going on. One more thing that we measured that I thought was pretty interesting is Diamanti has a Prometheus database, a time series database that captures a number of metrics, but the ones we looked at were the actual disk latencies. And I got excited about this because I like to see microseconds. You don't get to see that very often. And there was some, we're talking, 200, 3, and even when we scaled up to a larger data size, it didn't change that much. It went up just a little bit in terms of disk latency with it, and we're talking microseconds. So that was an exciting number to see. And then the last thing we did, then I want to get Arvind's opinion on a few of these things, but the quality of service was an interesting also measure we did. We also did, just with Diamanti, we did a saturation test where we spun up about 16 pods, SQL Server pods, and we hammered them with HammerDB and to see what, because they have this storage configuration where you can pick a level of service, and you can have a high, a medium, a best effort. Probably you can define more, but what was interesting to see how you can also prioritize certain applications. So you have a really a production SQL Server that is very important to your business. You can put it in the high category, and it always gets great IOPS. If you have one that's less important, or a DevOps or a QA or something else that's of less importance, you can drop it down into one of the lower categories. And so it takes the whole pipe, the whole bandwidth, and it divides it up equally and shares it amongst that. And I wanted to show that this chart was through their control plane, and you could see that go on. So I want to turn it over to Arvind, but I think we have a polling question, so let's do that first.
Yeah, well, before we actually push out the next polling question, let's take a look at the results of the first one.
Oh, thank you.
And here are the results here. Looks like the majority of folks are using on-premises virtual machines to run their SQL Server databases, followed closely by Azure. So I don't know if that's going to be changing after your presentation here, but we'll go ahead and hide these results, and then I'll push out the second polling question. And it should be coming up right now. What is your top challenge related to deploying and scaling your containerized SQL Server app? You can choose from performance, high availability / disaster recovery support, or cost efficiency. So go ahead and make your choice, and I'm going to leave this poll up for just a little bit here while everybody makes their choice. And while we are waiting, just a quick reminder to the audience that today's event is being recorded. So if you miss any or all of the event, you will have the opportunity to access it later on. In addition to us sending out an email after the event that will contain a link to access the webinar on demand, the webinar will also be on the DevOps.com website, so you'll be able to find it there as well. Also, a quick reminder that we should have a few minutes for question and answer period. So if you do have a question for Jake or for Arvind, when Arvind does his presentation, please go ahead and use your GoToWebinar control panel at any time. You do not have to wait for the question and answer period to submit your question. All right, with that, I'm going to go ahead and close out the poll now in 5, 4, 3, 2, 1. Closed it out, and we will share the results before we get to the question and answer period. So with that, I'll pass it back over to you guys, and you could continue your presentation.
Yes, thank you. And so yeah, as before, I conducted these testings. We did at McKnight together, but we're not Diamanti engineers. So I think I want to let Arvind now take the opportunity to share a little bit more detail about the Diamanti platform, so that you can have a little bit deeper look under the hood. So Arvind, I'll let you take it from here.
All right, thank you, Jake, and thank you, Charlene. So I think this is a wonderful report, and one thing I would like to reiterate again, that it might look like that report points to Diamanti being superior to other platforms for running SQL Server, but that's not the intention here. And I can really tell you how much effort Jake and his team did to make sure all his runs are completely unbiased to any of the platform. And also just to mention that this report only talks about the price and the performance metrics where Diamanti really shines. But there could be many more reasons where you want to run SQL Server on public cloud instead of on-premises. So it's a completely your choice, and sometimes it does make sense to run on a public cloud. So, and Diamanti is a hybrid cloud platform, so it can help you whether you're running it on-premises or on public cloud everywhere. And hybrid cloud is the future, so we support all the cloud vendors. So anyway, so Jake asked me, what is the secret sauce behind this amazing number we saw in this report? And I would like to cover a few important points which could be useful for audience to understand here. So as mentioned earlier in one of my earlier slides, that in Diamanti intro slide, Diamanti is a complete Kubernetes solutions built for hybrid cloud. And this diagram further illustrates that. So Diamanti offering have two major components to it. First one is the software offering, and the other one is the hardware offering. The software offering is Diamanti Spectra and Diamanti Ultima, which could run on any public or on-premises cloud, and gives you uniform control plane and data plane to run Kubernetes workload anywhere. So together, these two provide full spectrum of enterprise Kubernetes features like multi-tenancy, multi-cluster management, infrastructure management, application lifecycle management, observability, and many more. And on top of all these, it brings state-of-the-art data services to the hybrid cloud, which are very important. For example, synchronous mirroring, replication, snapshot, backup, restore, volume resizing, encryption, cloning, DR, and most importantly for hybrid cloud, migration and failover of application across the clusters and cloud. So you can easily migrate your SQL Server application, for example, maybe from Azure to Diamanti or Diamanti to Azure, or maybe to AWS. So you have all the choices right there. So the second suite of product offering is the hardware, which is essentially to boost performance of your on-premises data center. But same time, it reduces the footprint as well. So you can choose either the Ultima offload card, which fit with many different OEM x86 server, or you can build your future with Diamanti's bare metal hyper-convergent offering, which is all-in-one solution for on-premises data center, and which was actually used for this benchmarking exercise. As you can see, the HCI platform, which is mostly in the middle, you see in this diagram, it contains everything you need to run any kind of Kubernetes workload, either stateless or stateful application like Microsoft SQL Server. It contains Kubernetes, container runtime, operating system, compute, storage, virtualization, or networking virtualization, or even CSI, CNI from Kubernetes perspective. So basically anything and everything you might need to run your workload. So simply you can say turnkey and ready to deploy platform. So either you take software offering or hardware offering. In either case, these are built with only one thing in mind, and that is containers and Kubernetes for hybrid cloud. Now, talking about the hyper-converged infrastructure, which was used in this exercise, there's so many hyper-converged infrastructure vendors. Question is how and why Diamanti is still able to outperform this. So let's talk about that. Jake, can you please move to the next slide? So by definition, when you're talking about hyper-converged infrastructure, that means it's an all-in-one box. Compute, storage, networking are all in one. Right? But if you look at the previous generation of HCI, you will see that most of these functionalities was done at the software layer. And there was a reason, because everybody wants the software-defined approach, right? But in reality, this adds additional overhead to the host. Your networking and storage stack is all running in software. And on top of that, there is a hypervisor, VMs, with guest OS and all. So think about how much host overhead it adds up. In some cases, it could be like 50, 60% of the resources could be used up by this extra layer of software stack, right? So this adversely impacts application performance and increases the latencies, and the TCO is very bad. And at the end, no performance guarantee for the application running on the same host, because your VM is running on the same node, and if one VM is behaving badly, it can impact the performance of other VM, or essentially in this case now we're talking about container world, so container running on top of VM. So it's a shared infrastructure on top of shared infrastructure. So many vendors have tried to take the approach of hardware offload to offload some of these stack, as you can see under Hyperconverged 1.5, Hyperconverged 2.0. But still, in most of the cases, you will see that containers are still running on top of VMs and hypervisor. Jay, can you hit next, please? So, but with Diamanti, since the beginning, we made this platform for containers and Kubernetes only. So everything on Diamanti is optimized for containers and Kubernetes, with all the storage, networking, security, and management feature offloaded to the hardware acceleration card. There's no overhead on the host itself. So, and with true bare metal architecture, there's no hypervisor, no VM. So all the host resources are actually available to run the containers or application with very low latency and very high performance, as you already saw in the result. So this gives you very high container application density per node, while same time boosting the performance and reducing the data center footprint. As you can see that on the same set of resources, you don't have any hypervisor, you don't have networking, storage, everything is offloaded to the hardware. So all the resources are available to run your actual applications there, or containers. And this is very, very important to see this kind of performance. Jay, can you please move to the next slide? So in addition to the hyperconvergence, another factor is we're reducing the host overhead, but another important point is we are accelerating the networking, storage, security, and management using the hardware offload card. So out of all, the most important part for the SQL Server or any stateful application is the storage acceleration itself. So we have built the whole storage stack from the scratch, keeping containers and Kubernetes in mind. With many patented technologies in place, we have optimized all the layer of storage step. So all the way from the file system to embedded to SRIO virtualization, and but still we're making sure that from a user perspective, you get the same NVMe experience. So with all this optimization we have done on Diamanti storage layer and rest of the networking stack, we'll get a high performance storage system for Kubernetes, and even at full load, you'll get the ultra low latency, like you saw in Jake's report that it was around 200 microsecond as an average latencies. And that was when we were hitting almost 1 million IOPS per node, and that was 4K million IOPS. So, and on top of this performance improvement at the storage layer, as Jake showcased the quality of service slide. So Diamanti has the hardware-assisted QoS, which provide guaranteed SLA for storage networking, so that your workload is safe from any noisy neighbor, and you never need to over-provision anything. You can easily guard your application against noisy ones when using Diamanti QoS, and even if they're running on the same node as in other infrastructure, whether it's VM or container based, any noisy neighbor running on the same hardware node will impact your performance of your application, but not in case of Diamanti. So you have very high container or application density with very small footprint. So Jay, can you please move to the next slide? All right, so summarize everything. As you can see in this slide, it's not just about running the SQL Server as container. You need to take care of many things around the SQL Server ecosystem. There are many, there's like high availability, scaling, database management, user management, and many more. And most of that could be taken care by the application side itself, like SQL Server or Microsoft Big Data Cluster, which can manage the top layer, where what you see here. Jay, can you please hit next? But rest of the things which are underneath it comes from the platform you're running on. So all the storage, networking, and compute features are important to consider. And that's where Diamanti shines and brings everything under one umbrella. And that's with the highest performance and lowest TCO. So Jake, can you hit the next, please? So that's where you see all the bottom portion can be taken care by Diamanti platform, either you're running on premises or either running in hybrid cloud, public cloud. Everything can be taken care by the Diamanti platform itself. All right, I think I've already talked too much, Jake, and we are pretty much close to the end. So with that, I would like to pass it back to you.
Right, thank you so much. Yes, so to wrap this up and move quickly to questions, I just wanted to let you know that our full report, which has all the details in it, is available at Diamanti's website at this address here. Excuse me, and as well as our company websites. So with that ado, questions.
All right, yes, we do have a few minutes for questions. Before we dive right into them, though, do want to share the results of our last polling question, and just threw that up on the screen there for you. Looks like the top challenge related to deploying and scaling your containerized SQL Server app is high availability / disaster recovery support. Actually, all of these responses are kind of interesting and telling in how many people actually chose each one. Cost efficiency, I think, is a very interesting as the second highest challenge, but definitely worth considering in your conversations in the future. So I'm going to go ahead and hide these results now, and we'll dive into the audience questions. As I said before, if you have a question, go ahead and use your GoToWebinar control panel and submit your question. And let's take a look at the first one here. Let's see, are there any performance comparisons between SQL on Kubernetes versus bare metal Windows?
Yeah, I can take that one. Of course, as you obviously can tell, bare metal comparison was not in the scope of our testing that we presented today. And one of the challenges we have with it is the wide variety of configurations that can be used with that. And so it would be difficult to come up with, I think, a bare metal configuration that would be comparable to or meaningful for a lot of folks. And that's why we invite you to take a look at the report and consider doing your own testing using the same methods that we did. And if you have a bare metal environment that you're interested in knowing how it would stack up against these, you could follow the same methods and rigor, and you would get your answer there. So that'd probably be the best solution. I would love to see some testing, but again, it's difficult to come up with a configuration that would apply across the board to a great number of folks.
Okay, all right, good enough. Next question here, can you share more details on the benchmark used here? What tuning, block size, read write, random, sequential used?
I don't think there was, I think all that information would definitely be in the report as far as what you would need to replicate. We did not do, I think I stated earlier, we did not do any tuning to SQL Server or do anything kind of, we try to always conduct our benchmarks with sort of an out of the box configuration or as they would normally deploy. If we did do any tuning, which we didn't, we would apply them to all, we would make sure that it was something we could apply to all the competitive vendors. But in this case, the only thing really special we did was constrain the pod memory of SQL Server. And that was about the only thing that there.
Okay, all right, great. Let's see. Okay, next question here. And that's actually, this one is for you, Jake. Why did you pick up TPC-H instead of TPC-E? And what was the reason to choose memory as 32G specifically?
Yeah, well, again, I think I just answered the specific memory question. Again, we wanted to constrain memory in order to push as much I/O as possible. On the other question about why we chose TPC-H over some of the others, I think that we have tested both TPC. You can only do TPC-H or TPC-C with HammerDB. TPCE is a trickier benchmark to pull off, and there's not a publicly available testing harness for that. But with TPC-C, it's a transactional based, so there's a lot more read and write that goes on with that, and it doesn't saturate the I/O quite as well as the TPC-H does. And again, we really wanted to showcase the differences in I/O. And so the TPC-H offered us the opportunity to do that over the TPC-C, which is more measured in transactions per minute. And you don't see the same I/O characteristics because it does involve CPU and memory a little bit more. So that's why we chose the H over the C or E.
Okay, all right, great. I think we have time for one more question here. Were there any tests done on Red Hat OpenShift? I noticed the pod tested was RHEL 7.6, but the Kubernetes comparisons don't include OpenShift as a Kubernetes option / flavor.
Well, we did not. Jake, I think that. Oh, go ahead. Yeah, Arvin, please take it away.
Sorry, Jake. Yeah, so I can take that. So I think for this exercise, we did not do on OpenShift, but internally within Diamanti, we have done some similar benchmark run on OpenShift. Diamanti support OpenShift platform as well. So if you're familiar with OpenShift, OpenShift is just a software stack, right? So it depends where you're running it. So your performance will depend on what kind of storage system, what kind of compute behind you using it, right? So if you're using OpenShift on top of Diamanti platform, then yes, you will see exactly same performance what you have seen on pure open source Kubernetes performance as you saw in this report.
Excellent. All right, great. Well, unfortunately, we're 3 minutes to the top of the hour. That is all the time that we have for the question and answer period. I do want to thank everybody who did submit questions. And please note that if we did not get to your question, I do apologize. But the folks at Diamanti will be getting a copy of all of the questions that came in, and I'm sure they'll be more than happy to follow up with you offline to get an answer for you. Also, a quick reminder that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar will also be available on demand on the DevOps.com website. In the webinar section, just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, before we close things out, I did note at the top of the hour, we would be doing a drawing for 4 $25 Amazon gift cards. So without further ado, let's go ahead and do that now. Our 4 winners today are Danny A. Congratulations, Danny. Nick R. Congratulations, Nick. Edward Z. Congratulations, Edward. And our final winner today is Mike H. Congratulations, Mike. We'll be following up with all 4 of you via email to get your Amazon gift card over to you. So please check your inbox. If you don't see anything in your inbox, please check your spam folder. All right, Jake and Arvin, thank you both so much for a great presentation. Lots of extremely useful information. And judging from the number of questions that came in from the audience, I know they got a lot out of it too. So, still have a lot of questions there for you guys to answer. So thanks again, really appreciate it. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.